Section 8.5, number 7, we're going to start by graphing the curve using a 3-column table, and then we're going to use the process of eliminating the parameter of t to verify that graph and write it in rectangular form. So let's see here. Let's start with part A. Let's do a 3-column table. My graph has x and y's, but my relationship to get x and y, I need t, because I don't know what the relationship is between x and y. So I'm going to plug in some t's in that interval of, let's do -3, I like zeros, I like ones. So let's do those and see if that gives us a nice shape. If not, we can always come back and plug in a few more points. So let's see, -3. Plug that in for t. For x, I get -3 plus 2 gives me 1. And for y, I get -3 squared is 9 minus 1 gives me 8. Repeat that for 0, and I get 0 plus 2, which is 2, and 0 squared minus 1, which is -1. And repeat that for 1, and I get 1 plus 2 gives me 3, and 1 squared is 1, minus 1 gives me 0. And let's repeat that for 2. So 2 plus 2 gives me 4. And maybe we should have done a -2 because that, for x, that gives us 0. And -2 squared, so that's 4, minus 1 gives me 3. That's kind of neat. Let's see what else we have here. 2, plugging in 2 for y. So that's 4 minus 1, which is 3. So there's going to be some repeating digits here. Starting to look like a parabola. And then 3, plugging our 3 in for x, we get 5. And 3 in for y, we get 9 minus 1, which is 8. So let's plug those 4 points into a graph. Okay, so I made myself a graph here with, you see most of my numbers are positive looking at these 2 columns. So I only need to go to -1 in the y column and up to 8 in the y column and 0 to 5 in the x. So I made a grid to match those numbers. So let's do 1 point at a time. So here we got, oh, you know what? We only plot the x and y because there's no t on this. So 1 and 8 is right here. And then 2 and -1 be down here. And then 3, 0. Oops, I missed. No, that's good. And then 1, so 3, 0, 4, 3, 4, 1, 2, 3. And then we have a 5, 8, and a 0, 3. Well, you know, something doesn't look quite right. This guy looks like I made a mistake, so that was the first one, 1, 8. I do have an error there, if you can see. I plugged in -3 for x, which would be -3 plus 2, which should have given me a -1. Okay, so that one should be over here. That looks better. Now that's starting to look like a parabola. So a nice curvy shape so it doesn't look like a absolute value. And there we go. Okay, so that's how we graph with the t-table. Now let's do part B and eliminate the parameter. See if we get the same graph. So we're going to find an equation in rectangular form. So it should be, looks like it's a parabola of the form y equals x, and then x has been, this is the parent function equals y equals x squared, but we've shifted it, you can see, down 1, so that'll be a -1 over here, and over 2. So we're looking at a parabola centered at, oops, sorry, this should be a negative because the x is always the opposite shift. So that's a -2, 1. Whoops, sorry. Shifted, the center is at 2, -1. There we go. So we should get that when we eliminate the parameters. So let's do that. So for x, we're going to do, let's see, solve for t in this first equation. So take this guy, let's solve for t. And we get t equals x minus 2. Now I'm going to plug that back into this one. So plug that back into this guy, and I get y equals, and for t, instead of writing t, I'm going to write what I just solved in the previous equation. So I have y equals t squared minus 1, but for t, I write x minus 2, because that's the equation. That's what I got right here. So that gives me, then I got to FOIL that out, so that gives me x squared minus 4x plus 4 minus 1. Combine those like terms, I get y equals x squared minus 4 plus 3. 4x, sorry. So that is a rectangular form of, whoops, sorry, this equation. This one's in, oh, I forgot the name of the form, but this one's in standard form, and this is a I guess vertex form or something like that, some kind of graphing, easy to graph form. But those are the same equation if I complete the square on this side, which is outside the scope of this class, so I'm not going to do that right now. Then those equations are equal, so I can see that this is my answer for the rectangular side. So this question had 2 parts, so I'll highlight both those answers. Whoops, wrong color. I like yellow for my answers. So one part was that graph with those points, and the second part was the rectangular form of the equation, eliminating the parameters. This part, oops, sorry, let me get I don't know. This part over here I kind of did a little bit for fun, I guess. I just like to see what I'm working with, but it's not necessary, it's not part of the answer. But I like to kind of see it matches. So that is my final answer, the graph and that rectangular form of the equation for parabola.